For part C, we have f of x equals x squared minus x minus 12 divided by x plus 5. Now you'll notice that I have done a lot of the problem already. So the factored form, I've already written that, and then once we have the factored form, we can find the domain. That means that we're going to have to exclude the x value of negative 5. This particular problem doesn't have any factors that are common to the numerator and the denominator, so there isn't any need to do any cancellation. Next off then, the y-intercept would be negative 12 over 5. The x-intercepts come from the zeros of the numerator, so we have 4 and negative 3. The vertical asymptote comes from the zero of the denominator, so we have a vertical asymptote of x equals negative 5. So the interesting thing about this particular problem then comes down to talking about the horizontal and oblique asymptotes. So let's once again think about that handout from section 2. We need to find whether we're going to have a horizontal or an oblique asymptote. And it comes down to thinking about the degree of the numerator and the degree of the denominator. The degree of the numerator here is 2. And the degree of the denominator is 1. So that means that the degree of the numerator is greater than the degree of the denominator, and it's greater by 1. Well, once again, from our handout from section 5.2, that means that we will have an oblique asymptote. If we have an oblique, we can't have a horizontal asymptote. So we'll start by writing down none on the horizontal asymptote. So then the question is, how do we find the equation for that oblique asymptote? We saw this back in section 5.2. It's going to be polynomial long division. So we're going to have x squared minus x minus 12. We're going to divide that by x plus 5. So the first question is, how many times does x go into x squared? The answer is going to be x times. Multiply the x times the x, we're going to get x squared. Multiply the x times the positive 5, we're going to get positive 5x. Once again, the safest way to move forward then when you're subtracting these polynomials is to change every sign on that second polynomial. So positive x squared becomes negative, positive 5x becomes negative. The x squareds cancel, and we have negative x plus a negative 5x. That's going to be negative 6x. Bring down the negative 12. How many times does x go into negative 6x? Negative 6 times. Multiply negative 6 times the x, we're going to have negative 6x. Multiply the negative 6 times the positive 5, we're going to have negative 30. Change both signs. Negative 6x and positive 6x cancel each other out. Negative 12 plus 30, looks like we're going to have an 18 there. So now that we have this, the quotient here is going to tell us our oblique asymptote. Once again, the oblique asymptote is always written down as an equation, so we need to put a y equals in front of that, and we now have the equation for the oblique asymptote. Y equals x minus 6. Now, when we draw an oblique asymptote, remember that it is an asymptote. So it's not going to be a solid line. It's going to be a dashed line. So we want to draw y equals x minus 6 as a dashed line. Well, this is a line that is in slope-intercept form. So because it's in slope-intercept form, I actually know quite a bit about that line. I know that it has a slope of 1, and I know that it's going to have a y-intercept of negative 6. And once I have those two pieces of information, I know where my line has to go. So I'm going to come down here to negative 6 on the y-axis, and if I have a slope of 1, that ultimately is going to tell me that we're going to have to go through positive 6 on the x-axis. So I'm going to go through both of those tick marks. So let's go ahead and put a dashed line that goes through both of those values. So now that I have this, then I can go ahead and use our intercepts and our sign chart and all these asymptotes to figure out what our graph is going to look like. So as you look at the sign chart, it says then on the left-hand side, to the left of negative 5, our graph has to be below the x-axis. But it also has to approach all of these asymptotes. It has to approach the oblique asymptote of y equals x minus 6, and it also has to approach this vertical asymptote of x equals negative 5. But once again, you have to see what isn't happening here as well. We don't have any x-intercepts, so we wouldn't go swooping up forever like this, because that would end up meaning that we would have another x-intercept in a place that we don't. So the only way that we can actually approach these two asymptotes and stay below the x-axis is to have a graph that looks something like that. Now let's keep going. Between -5 and -3, we know that the graph has to be above the x-axis. Well, we're going to go through the x-axis at -3, and to be above means that we're going to swoop up like this. And then as we continue to the right, the sign chart says between -3 and 4, our graph has to be below the x-axis. We also know that it has to go through the y-intercept. So we're going to be below the y-axis and go through all of those intercepts. And then finally, our sign chart says to the right of 4, our graph has to be above the x-axis. And the only other thing that is of interest over on the right-hand side is this oblique asymptote. So we have to approach that oblique asymptote as well. So we'll get closer and closer and closer to that oblique asymptote. So there's our graph for part C.